Yes, sir. Shashi, sir, is it live now?
यस मैम वी आर लाइव नाउ। मैं आपको लिंक शेयर कर रहा हूँ व्हाट्सएप पे ना।
हाँ जी, please. So we will start exactly at 1.
Okay, ma'am.
मैडम लिंक व्हाट्सएप कर दिया आपको।
Yes, sir. I'll share in the group. Yes, sir. So we are going to start now, sir. So good afternoon, everyone. I am sharing my screen. Shashi, sir, I hope my screen is visible.
Yes, ma'am, it is visible.
Yes, sir. Thank you, sir. Just a minute. Yes. So we are starting for the webinar. So live as if you were to die tomorrow. Learn as if you were to live forever. So let's start with these words by Mahatma Gandhi ji. So we are here to attend this webinar. So I, Dr. Narinderjeet Kaur, welcome you all on behalf of KMV Fraternity on this one-day national webinar on natural dyeing and its applications organized by PG Department of Chemistry and Fashion Designing, Kanya Mahavidyalaya, and it has become a regular aspect and part of Kanya Mahavidyalaya to organize such academical programs. I would like to take this privilege to acknowledge our worthy Madam Principal, Professor Atima Sharma Dwivedi ji, in her absentia, for always encouraging us, and it gives immense opportunities for our round-the-clock development. I would like to welcome our esteemed speaker of the day, Dr. Parambir Singh Malli ji. He is a distinguished expert in the field of natural dyeing, renowned for his extensive research and innovative applications. Let me say a few words about our institution, Kanya Mahavidyalaya. Kanya Mahavidyalaya, a distinguished, autonomous and heritage institution, has played a monumental role in advancing women's education over centuries. Recognized for its excellence, KMV holds A grade accreditation from UGC NAC, along with prestigious titles like College with Potential for Excellence and Star College status by DBT, and FIST and Curie grants by DST Government of India. Ranked among the top national magazines like India Today and Outlook magazine as autonomous #1 college, KMV continues its legacy of fostering, learning, and empowering women. So let's let's proceed further for this webinar. So before that, let me introduce our speaker of the day. With a wealth of knowledge and experience, he brings a unique perspective to the art and science of natural dyes. His upcoming lecture promises to enlighten audiences on the fascinating world of natural dyeing and its diverse applications across various industries. So Dr. Parambir Singh Malli ji did his BTech in textile chemistry from GNDU in 2003, joined our group of industries in the dyeing department through campus placement. He did MTech in Fiber Science and Technology from IIT Delhi in 2006, joined Advan Textiles Limited in 2006 through campus placement, and worked in the process and product development department. He joined Nahar Group of Industries in 2009 and worked as a manager, quality assurance and customer care department. Joined Guru Nanak Dev University as assistant professor in 2010 and did his PhD in chemistry from GNDU. And his area of specialization is eco-friendly textile pre-treatment, dyeing and finishing. So we are here to welcome Dr. Paramveer Singh, sir. So
Thanks a
over
lot,
to you,
ma'am.
sir. Yes.
Thank you, ma'am. Should I share my screen, ma'am?
Yes, sir. Yes, sir, please.
Thank you. Hello, everyone. Myself, Paramveer Singh
Yes,
Mali,
sir.
and
It's
Dr.
visible.
Narendrajit Baba have already given brief introduction regarding me. Before I start my topic on the natural dyes, first of all, thankful to Dr. Atma Sharma Trivedi ji, principal of the KMV. I'm also thankful to Dr. Manju Sahni ji, head PG Department of Chemistry, Dr. Harpreet Kaur ji, head Department of PG Fashion Designing, and at the end, I will be thankful to Dr. Narinder Kaur ji, who invited me to give a lecture. So I will today I'm going to give an introduction regarding the natural dyes and their applications. Although natural dyes are the very vast topic, and it is not possible for any person to cover this within 1 hour, but I will try to cover maximum as much as possible and try to introduce you to the natural dyes and their applications. So if I will talk about the natural dyes, are before natural dyes, I will just give a definition of the dye. A dye is a color substance that chemically bound to a substrate to which it is being applied, and generally dyes are applied using aqueous medium and to enhance their fastness properties. Generally, we use the mordant to enhance the fastness properties of dyes. And regarding the classification of the dyes, these can be classified by the different methods. So one is based on the application method, whether the dye is basic dye, acid dye, direct dye, mordant, reactive, disperse, solvent, sulfur, or wet dye. And when we classify them on the base of the structures, the dyes can be azo, anthraquinone, polymethylene, indigo, hyoscyanin, or nitro dyes. And we can also classify the dyes on the base of their source of material. That is our today topic, that is natural dyes, and they can also be classified as synthetic dyes. You can see the colors around us. In our daily life, we have gone through many colors. So here I have given an idea that the colors are present in our nature in the form of grapes as a red-blue, red pink as a beetroot. You can have a saffron color, saffron, carrot, mango, turmeric, marigold to give the yellow, orange, red hues. You are using henna as a mehndi in your daily life, so it gives a green color. Right now, we have a mulberry fruit season. So you can, in our local language, we call it the shatut. You can see the many mulberry trees are there, and you can see the dark purple or navy blue color shoots are there. And then in the coming days, we have a jamun. So these colors are around us. So the nature already provides us the colors to color our foods, our toys, our you can say textile materials. So before going to the natural colorants, I will just told you that they are not new to us. So from the ancient Stone Age days, we are using the colors as the powder minerals, and then in the ancient India, madder, turmeric, henna. Madder is a majid. In a local language, we call it as a majid. The turmeric as a haldi, the henna as a mehndi. These are used in the ancient India. In the Egyptian countries, the indigo was used, the madder was used. In the North African ancient, the madder, cochineal, canis are used. So these are not new to us. These are, you can say, from the day the textile material are introduced, so the colors are also introduced from the nature. So we can also have a natural dye references from our holy books. You can have a Gurbani from the Sikh holy book. So they have also mentioned the natural colors, and also also given an idea that how these colors are fastened to our material, like in Sui Mohalla one Pehla Kar Nova, Kacha Rang Kusum Da Thothadiya Din Cha Jiyo. The color of safflower is basically a kusum is a tree, and the leaves are taken to extract out the color. So they are not fastened color. They lose the color very easily from the material. And then from the Var of the Pai Gurdasi, Rang Majid Kusumda, Kacha Pakka Vichare. So here two natural dyes are mentioned. One is the madder, that is the Majid. The Majid give a permanent color, and the Kusum, that is a safflower, already told that they give the temporary color. So in the Gurbani also they mentioned that whether these colors are permanent or temporary on the textile material. So we will talk about the natural dyes as we have a today topic. So natural dyes are not new to us. They are old as the textile materials, and the nature provides us a wealth of the plants, animals, and minerals which will yield their color for the purpose of dyeing. And many have been used since antiquity, and these colors are known as natural dyes. There are the different sources of the natural dyes. The main sources are the plants, animals, minerals, and microorganisms. And here we give an example of the sources of the material like turmeric, Spanish, taken from the plant, and they give the yellow and the green color respectively. In the animal, koti, neil, and the shellfish give the red.
Sorry, sir, your presentation slides are not moving. You have to share your screen again.
Okay, madam.
Hanji. Yes, sir. Now it's moving.
It is visible now, madam. So I think I should continue with this way, in this mode.
Sources of natural dyes slide
Yes,
is
yes,
visible.
yes. I am showing this slide.
Yes,
Is
sir.
it visible?
Yes,
Now
sir. It is visible.
So sources of the natural dyes are there. From the iron, from the chrome, we can get the black and the gray color. But till 19th century, these dyes are used widely in our daily life. But the introduction of the synthetic dyes in the 19th century is around 1950s, when the synthetic dye was introduced. So they replaced the natural dyes. We will discuss later on why these dyes got replaced. So India is one of the rich biodiversity country in the world, 12 mega diversity countries. And in India, we have around 4,90,000 plant species. And out of these, 450 plant species are dye producing, and among them, 40 to 50 are considered as very important. And it is also very important to mention here that dye is not a dye taken from the plant, is not a single compound. It is generally a complex of the many compounds like presence of the tannins, anthocyanins, flavonoids, and the phytochemicals. So not a single compound is responsible for the color in a plant. So you can have a color varying from the season, time, the color of the fruits, the leaves changes with respect to period and time, climate, temperature also. So if we will classify the natural dyes in terms of chemical constitution, the first dye is known as the indigo dye. This group includes indigo and the tyrant purple blue dye. So the jean you are wearing in your daily life is dyed by the indigo dye. I gave an idea regarding the color of the indigo, and this is the dye structure, and this is the plant from where it is extracted. And although before 19th century, most of the jeans are dyed by the indigo dye, but when the jeans trend was drastically increased in 1970s, the production of the indigo as a natural dye was very low. So there was a challenge in the industry that how to get the more indigo dye. So scientists developed the synthetic indigo dye and having the same dye structure. So right now, these days, synthetic indigo dye was used to fulfill the requirement of the industry. Then the second important dye class regarding chemical constitution is the anthracnone dyes, and most of the red natural dyes are belong to these dye class. The madder, magic, black, cochineal are some of the example of this group. And alizarin and purpurine are the two main chromophores used in these natural dyes to give the color substance. Then the another class is the alpha naphthoquinones, and Hina belong to this dye class. And the another dye class belongs to this is a Jaclone, which is taken from the shell of the unripe walnuts. And then the flavonoids, these are very commonly known to the food industries also. They are the yellow dyes, and these are the alternate structures of the flavonoids. Then we have carotenoids as used to be derived from the pigment found in the carrot, and they give the color because of the conjugated long chain of the double bond structure. And most of the red, orange, yellow colors are coming from this category, and we can get them from the sunflower, mango, marigold. And now I go into some of the structures of the turmeric dye, tea dye, very common natural dye, and the onion peel. The peel of the onion is used to extract the dye, and this is the dye structure. The saffron, the kesar we use in our daily life as a food additive or for the tilak. And the natural color of the saffron is a purple, but in the presence of water and air oxidation, air oxygen, it gets oxidized into yellow color. Then the pomegranate rind, that the peel of the anar, the tannins are there which give the color, and they can be used as the dye material to dye the textile material, or can be used in the food substrates also. Then the cochineal is a basically insect-based dye. It is also anthracnone based, the lac insect, and the jackfruits. The dye taken from the woods of the jackfruit generally used to.
Sorry to interrupt you, sir. Actually, the slides are not moving and they are not visible to the participants.
I think I should use this mode.
Sir, if you can put your slides on a slideshow mode, it will be.
I am showing on the slideshow mode, but you are saying that the slides are not moving. That is the issue.
Okay. Yes,
now
sir.
It is.
So we are on the structures of onion and saffron.
Now it is moving or not?
Sir, now you have moved the slide.
Okay.
Yes.
So these are some of the structures of the dyes like turmeric dye, tea dye. Is it moving? Onion, saffron.
Yes, sir. This slide is visible. If you can put it on slideshow mode, sir, that will be much better.
I am already showing on slideshow mode, madam.
No, sir. No, sir. No. It's not visible on slideshow mode, sir. I think you should stop sharing and again share the slides.
Okay, madam.
Yes, sir. Now put it on the slideshow mode, sir.
I have put it on the slideshow mode.
No, sir. It is not still.
On my screen, it is a slideshow mode.
No, sir. You have to put it on the slideshow mode, sir. नीचे या ऊपर.
ये slideshow mode नहीं है. ये मैंने
नहीं, sir. No, sir. It is not a slideshow mode, ना, sir. ये सिर्फ एक presentation है. ऊपर आप मेन्यू बार में देखेंगे ना, slideshow.
एक मिनट मैडम.
सर सबसे ऊपर स्लाइड मेन्यू बार में स्लाइड शो जहां लिखा है आप उसको क्लिक करिए.
मेरे यहाँ से तो स्लाइड शो, मैं जो प्रेजेंटेशन दे रहा हूँ स्लाइड शो पे दे रहा हूँ.
नहीं सर, हमें नहीं विजिबल
नहीं आ रहा.
हाँ, अब हमें सिर्फ आपकी सिंपल पावर पॉइंट प्रेजेंटेशन नजर आ रही है. एक साइड पे थंबनेल्स एंड वन स्क्रीन इन द मिडल. स्लाइड शो पे सर सबसे ऊपर आप देख रहे हैं, आप इसमें होम, इंसर्ट, डिजाइन वगैरह लिखा है. वहां देखिए स्लाइड शो लिखा हुआ है 5th नंबर पे.
ऑडियो, वीडियो.
So you can share your slides with me if you want.
Is it now slideshow?
Yes, sir. Now it is on slideshow.
It's
Yes,
so
sir.
slideshow? Okay, madam.
Yes.
So,
sir.
sorry for the problem from my side, but it is not.
We are in that slide of jackfruits, lac insect with chemical structures.
So, is it now slideshow?
Yes, sir. Yes, sir. Now it is
So,
visible.
these are the structures of the onion, then saffron, then pomegranate grid, then cochineal, lac, and jackfruit. And then we can classify the dyes on the base of application also. So, as I said in the starting, that these dyes can be called as a direct dye. So, turmeric is a dye which can be called as a direct dye, and it can be applied directly from the aqueous solution. So, generally, these dyes shows the substantivity towards the fiber. Substantivity means उसकी तरफ जो डाई है वो बहुत जल्दी जो है कॉटन के ऊपर चले जाती है या किसी भी फाइबर के ऊपर चले जाती है. दैट इज कॉल्ड सब्सटेंटिविटी. सो टर्मरिक इज अ डाई विच इज बिलोंग टू दिस क्लास. Then wet dye. Wet dye is a generally water insoluble dyes, and they get solubilized by reduction method. And we use the reducing agent like sodium diethionite and sodium hydroxide as alkali. And after dyeing, these dyes are reoxidized to regional form by air oxidation or using hydrogen peroxide as oxidizing agent. And indigo dye fall under this category. Then the modern dyes, most of the dyes are modern dyes. Natural dyes are, most of the natural dyes are modern dyes. And we use the modern to make a bridge between the dye and the fiber. So I will show you some mechanism later on regarding the modern. And then the dispersed dyes are the low aqueous solubility dyes. So they do not have a solubility in the water. So you have to add some extra agent to make them solubilize in the form of dispersing agent. And then the two different classes are there also, acid dyes and basic dyes. Acid dyes are the one which are applied to the acid medium. There are dye molecules are there like sulfonic groups or carboxylic group in the dye molecule, which make a electrovalent bond, that is an ionic interaction between the amino group of the wool and silk. And then in the same way, basic dyes having a positive charge, having a carboxylic group. So they make interaction with the carboxylic group of the wool and silk. So this is the introduction regarding the natural dye. But the challenge is there that how we will extract the dye. So that is what the area focus we need to understand, that how we will extract the dyes. We know that dye sources available in our daily life or surrounding, but the challenge is the extraction of the dye. So there are different methods are there for the extraction of the dye. The first is the aqueous extraction. The aqueous extraction means that we will use the deionized water to extract out the dye molecule from the raw material. Whether the raw material is a flower or it is an insect or it is you can say a leaf or from the bark, we chopped it and converted into a powder. If it is a liquid, we can grind it and it converted into fine paste, and then we would boil it. When we will boil it, the water soluble dye molecule will came out in the water, and we will filter out and use it in the next process, that is the dyeing. Whether you want to colorant the food material or you want to dye the textile material, but these aqueous extractions are having a very huge disadvantage, that it is a time consuming, and you need a high temperature requirement, you need very large volume of water, and the important is that only water soluble colorant can be extracted, because some of the colorants are not water soluble, so they are not able to extract it with the help of the water only. So we use the next method, that is acidic or alkaline. अब मैडम स्लाइड से चल रहा है ना?
Yes, sir. Yes, sir.
Okay. Now the second method, which was usually used, is the acidic or alkaline. It is the same as we have done in the aqueous solution. You can say the raw material is ground into powder form, and then powder form is dissolved in the water, boiled it. And if you need some acid or alkali, depend upon your experience and optimization of the material, you can use NOH or acetic acid for the pH of the solution. So you can boil it, then you can filter it, and then you can use the color solution. So this is the method in which you are changing the pH of the solution by adding acid or alkali. The next important method is the solvent extraction method. This solvent extraction method is widely used, and we are also using it in our laboratory also. I will show you one extraction later on. So organic solvent like acetone, petroleum, ether, chloroform, ethanol or methanol are used to extract the natural dye. So solvent extraction has a benefit that it gives a more efficiency than the aqueous method, and the yield is very good quality, required low temperature, and quantity of the water requirement is very less. And you can recover the solvent also for the reuse. So here we have extract out the solvent from the we have extract out the dye from the raw material with the help of a solvent, and then later on we can use this to dye the any material, whether it is a cotton or it is a wool or silk. This is one example I wish to show here, that as I told that the natural dyes are very complex. So you can use different methods for the extraction to extract out the dye. Here three mediums are shown: ethanol, methanol, and double distilled water. And they have taken the three different raw materials. And you can see the first material show extraction by all three mediums, and methanol gives the maximum dye yield. But in the second case, the red dye is extracted maximum by the ethanol and the least by the water. And in the last medium, all the three mediums show the dye, very good dye extraction. So it is very difficult for any scientist to define one method of extraction for the all natural dyes. Any dye can be extracted by any source, but for that you need an optimization in the laboratory. And then another method which is widely used is the ultrasonic microwave extraction. Here you will have a raw material which is having a dye and the waste product. With the help of the ultrasound waves, you can break the complex between the dye molecule and the other material, and then the dye molecule will get solubilized in the aqueous medium, and you can extract out this dye for the use. So the benefit is that you will use the very low temperature, very low energy, and very less time, and this will fasten the extraction method as compared to aqueous method. Then enzymatic extraction is also there. So commercially enzymes are there. If you know about the application of the enzymes are very specific to the subject. Like cellulase will attack only on the cellulose, amylase will only attack on the amylase, pectinase will only active on the pectins. So like we have a bark, roots, and hard part. So these enzymes are applied on these bark, roots, and hard part of the plant, and these enzymes will break the complex structures and release the dye molecules, which can be filtered on and then used in the application method. So this is just a brief idea that how we will use the extraction method. You have a plant, you can grind it, and then you can select a solvent, and from the solvent you can use the extraction method. So this is just a brief introduction regarding the extraction method. After extraction, you can separate by the different chromatographies, and then to confirm whether the dye extracted is okay or not, you can use the characterization by using ultraviolet spectroscopy, FTIR, and then you can use these dye for the dye. Now this is an example. We have extracted the marigold from the marigold flower. So we have used the solvent as a ethanol, and we heat it, and after heating the solvent, the dye get solubilized in the solvent, and then we do filtration, and this is the marigold dye extracted from the marigold flower, and this dye is later on used for the dyeing of the different fibers. So in a very simple way, I can say the natural dye will able to dye cotton, silk, flax, wool, and some of the synthetic fibers. But the dyeing faces many challenges, and out of these, the first challenge is the fastness challenge. If we will talk about the fastness challenge, the natural dyes show very poor light fastness and very poor washing fastness. And the reason is the photo-oxidation of the chromophore in the case of natural dyes, and the poor substantivity of the natural dyes toward the substrate. Poor substantivity means कि जो डाई है वो फाइबर के ऊपर जा ही नहीं पाती है. हम अगर उसको फाइबर को डिप भी करते हैं डाई सॉल्यूशन में, तो डाई जो फाइबर के ऊपर नहीं जा पाती. दैट इज कॉल्ड लो सब्सटेंटिविटी. सो द सॉल्यूशन इज द मेटल साल्ट्स. So metal salts, or you can have a tannins. So these are called mordants. So mordanting is a very important part in the case of natural dye. So what are the mordants? Mordants are the natural color. The mordants are derived from the French word mordre, which means to bite. The mordant is a substance which have an affinity for both fiber and dye stuff, and so is used to fix on the fiber. Most of the natural colorants have no substantivity on the cellulose or other textile fibers. They require an intermediate to fix into the fiber, which is called a mordant. Mordant does not serve as a color source of its own, but they are basically act as a bridge between the fiber and the dye. So here I will show you the mechanism, reporter mechanism between the fiber and the dye. The tannin here in the first example is taken as a mordant. It makes a hydrogen bonding with the wool part, and later on when the dye was taken, the dye also make interaction with the tannin. So this is how the tannin acts as a bridge between the dye molecule and the wool fiber, and so are the metal salts. The metal salts make a coordination between the dye molecule and the wool fiber, and this will make a increase in the substantivity toward the fiber. तो इस तरह से dye जो है वो fiber की तरफ substantivity उसकी बढ़ जाती है. And this is the second interaction. Alizarin as a dye. Alizarin as a dye. This dye alizarin is taken from the madder, that is a majete. So you can have a textile fiber as a cotton. There are hydroxyl groups in the cotton fiber. So they make a coordination with the aluminium taken from the alum as a mordant. So this is how the aluminium act as a bridge between the fiber and the dye molecule. And the third example is there between the wool and the jaglon, which was taken from the walnut, and iron sulfate taken as a mordant, and it make a coordination complex with the dye molecule and the wool part. So this is how the mordant help us to make a enhancement in the fastness properties, and also help us to enhancement in the light fastness properties. So mordants are generally categorized into three categories: natural tannins, metals, and oils. So tannins are taken from generally from the vegetable products, generally available from the bark of the wood, and then the metals like alum, tin, chrome, copper, iron, and oils like turkey red oil or vegetable oils are taken as the mordants. Regarding the application of the mordants, here I have tried to show the three methods of the application. One is the pre-mordanting, meta-mordanting, and post-mordanting. So try to understand what is pre-mordanting, meta-mordanting, and post-mordanting. You will see these are called dyeing cycles. These are called dyeing cycles. You will need to see this dyeing cycle. Here in the pre-mordanting, we have a water, mordant, and fabric. We do mordanting, means हम पहले जो आपका फैब्रिक है उसको मॉर्डेंटिंग कर देते हैं. मॉर्डेंट आप चाहे टैनिन यूज कर लो, चाहे आप मेटल यूज कर लो, चाहे ऑयल यूज कर लो. The mordanting was done at 70 degree for 30 minutes, and then we will cold wash it, and then we will do a dyeing. This is the dyeing of the fabric after mordanting. पहले mordanting करेंगे, फिर उसके बाद dyeing करेंगे. In the case of meta mordanting, you can use mordant and dye in the same bath. तो dye और mordant दोनों ही same bath में आप इस्तेमाल करोगे. And the third one is post mordanting. पहले आप dyeing कर लोगे, dyeing करने के बाद आप उसको mordanting करोगे. All the three methods will give the different results. इनके जो रिजल्ट्स होते हैं वो भी डिफरेंट होते हैं. Mostly the pre-mordanting and post-mordanting give a darker shade as compared to meta-mordanting. And sometimes mordanting also change the color. So that is a very big problem in the mordanting with the natural dye, that sometimes the color of the dye changes with the use of the mordant. So इसलिए आपको पहले ऑप्टिमाइजेशन करनी पड़ेगी कि कौन सी डाई के लिए कौन सा मॉडरेंट जो है वो आप इस्तेमाल करोगे. So for that one you have to do some lab work. कि आप एलम के साथ जो सेम कलर रहता है, sometimes happen that with the use of the iron, the color of the dye changes from yellow to brown. So this problem arises when we use the mordants. Now, after understanding the mordant, we must know how to dye the natural dye. So generally, three methods are used: exhaust method, semi-continuous, and continuous. Exhaust method is the one generally we use in the labs. आप एक बीकर में पानी लेते हो, फैब्रिक डालते हो, डाई डालते हो, तो आप उसको स्टिरिंग करते हो. That is called the exhaust dyeing. Semi-continuous and continuous are mostly based on the machine base. ये मशीन बेस होते हैं, मशीन के ऊपर कपड़े को कंटिन्यूसली चलाया जाता है. दैट इज कॉल्ड कंटिन्यूस डाइंग. सो आई विल शो यू machine in the later presentation. So I will try to explain a few natural dyes, how we will do the natural dyes on the material. So first I will take the example of the madder. In the case of madder, we will take the extraction of the dye first. Here the extraction of the dye is done by the solvent extraction. तो सॉल्वेंट एक्शन में आप चाहे इथेनॉल ले लो, चाहे मिथेनॉल ले लो. आप इथेनॉल और मिथेनॉल के अंदर अपने जो रॉ मटेरियल है, आपका जो मैटर है, उसको आप बॉयल करोगे. बॉयल करने के बाद डाई एक्सट्रैक्ट होगी, जैसे मैंने आपको उसमें दिखाया था मैरीगोल्ड में. द एक्सट्रैक्टेड डाई विल देन अप्लाई अलोंग विद द हेल्प ऑफ द मॉडरेंट. तो मैटर डाई की जो सब्सटेंटिविटी होती है बहुत पुअर होती है फाइबर के प्रति, तो इसलिए हमें एलम या कॉपर को यूज करना होगा एज अ मॉडरेंट. So we can use any moderating method, pre-moderating, meta-moderating और post-moderating आपने मेथड लेना है. वो आपके ऊपर डिपेंड करता है. आपको पहले लेबोरेटरी में कुछ ऑप्टिमाइजेशन करनी पड़ेगी and dyeing will take place at 100 degree centigrade. So this is a dyeing curve for the post-moderate dyeing of the cotton with madder. So पहले आप जहां पे madder डाल दोगे, आप madder डालने के बाद टेम्परेचर इंक्रीज करोगे. You will increase the temperature up to 100 degree centigrade. Or then you will dye for 20 to 45 minutes, and then later on decrease the temperature to around 70 to 60 degree, and then you will add the acetic acid and the moderant. Here the chromium potassium chromate is used as a moderant. तो उसमें से जो chromium है वो आपका moderanting करेगा, and then you will increase the temperature again to the 100 degree temperature, hold it for 30 to 45 minutes, and then you will get the dye fixation on the cotton material, and then you will do the next process. So this is how you can dye the madder in the laboratory or in the industry as per your requirement. Now I'm here trying to show how to dye the cotton with the turmeric dye. Turmeric dye is the haldi we are using in our kitchen also. So extraction of the turmeric dye is also very easy. You can use deionized water. Deionized water इसलिए लेते हैं ताकि कोई भी उसके अंदर पहले से जो मिनरल्स हैं, जो मेटल्स हैं, वो नहीं होने चाहिए. अगर मिनरल्स या मेटल्स होंगे, हो सकता है कि वो डाई के साथ कॉम्प्लेक्स बना लें, एंड दिस विल नॉट चेंज इन द कलर इज देयर और डिक्रीज इन द सब्सटेंटिविटी ऑफ द डाई. सो यू विल एक्सट्रैक्ट द डाई इन द deionized water at 95 degree for 1.5 hours. After extraction of the dye, you will filter it and take the yellow color. The yellow color is used to dye the turmeric by the exhaust dyeing. So यहाँ पर आप पानी डालोगे, पानी डालने के बाद आप नेचुरल डाई डालोगे, टर्मरिक डाई डालोगे, and then you will add your sample as a fabric, and then increase the temperature to 80 degree centigrade, and the dye will go on the fiber, and after 20 minutes you will drain the dye bag. And if you feel that the fastness properties of the turmeric are poor, then you can also use pre-mordanting with the alum. So people have done mordanting of the turmeric dye with the alum also. So it is already reported, so you can get it. Now, dyeing of the cotton with indigo dye, I especially here introduce the indigo dye. The reason is that around 80% of the young people prefer to wear the jeans, and they must know that how the jean get dyed using the indigo dye. So if you have seen the jean is not totally dyed by the indigo dye. The one thread of the indigo, one thread of the jean is dyed by the indigo dye, and another is of white. अगर आप अपनी जीन को उल्टा करके देखोगे तो आपको बैक साइड पे ज्यादातर व्हाइट धागे नजर आएंगे, और जो फ्रंट है आपको ज्यादातर आपको ब्लू नजर आएगा. द रीजन इज दैट एक धागा जो होता है हमारा, जो वार्प इसको बोलते हैं, लंबाई वाला धागा होता है, इसको हम डाई करते हैं इंडिगो डाई से, और जो वेट धागा होता है, जो चौड़ाई का धागा होता है, दैट वाज रिमेन्ड अनडाइड एंड इट रिमेन्ड व्हाइट. और इंडिगो की प्रॉब्लम ये है कि इंडिगो जो है वो एग्जॉस्ट मेथड से डाई नहीं होता है. जैसे मैंने पहले बताया था कि आप एक बीकर के अंदर उसको डाल दो, बट इंडिगो अगर आप बीकर में डालोगे तो इंडिगो जो है वो फाइबर के ऊपर नहीं चढ़ेगी. So it is dyed by the dip method. So dip करने के बाद उसको पैड किया जाता है. पैड करना मतलब होता है दो रोलों के बीच में डाई को निकालना. तो ये आप देख रहे होंगे, मैं आगे भी आपको दिखाऊंगा. सो डाई जो है आप दो रोलों के बीच में से एक्स्ट्रा जो है वो स्क्यूज कर देते हो. पहले डिप करते हो, डिप करने के बाद दो रोलों के बीच में से स्क्यूज करते हो. The another problem with the indigo is that indigo is a wet class, so it is insoluble in water. So you have to reduce the dye into lithoform. Here I have shown that how the lithoform converted using the sodium diethionide in the presence of sodium hydroxide. So lithoform जो होती है वो lithoform की जो water solubility होती है वो अच्छी होती है. So you can solubilize the wet dye and then apply on the material. So ये मैंने एक इंडस्ट्री का एक पिक्चर लिया है. So इसमें आप जो वेट डाई देखते हो, जो धागे हैं आपके, जो कपड़ा नहीं है, धागे हैं, जो धागे हैं वो इसमें डिप किए गए हैं. डिप करने के बाद ये दो रोलों के बीच में इसको स्क्यूज किया गया है, एक्स्ट्रा लीकर को निकाल दिया गया है. So इस तरह के जो बात होते हैं, ये नंबर ऑफ बात बने होते हैं, 1 2 3 4 5. एक बार डिप किया, फिर इसको स्क्यूज किया, फिर डिप किया, स्क्यूज किया. स्क्यूज करने के बाद हम यहाँ पर इसकी ऑक्सीडेशन कर रहे हैं ताकि जो इंडिगो डाई है जो हमने रिड्यूस किया था उसको ओरिजिनल फॉर्म में कन्वर्ट करें. जो वाटर इनसॉल्युबल फॉर्म थी उसको कन्वर्ट करने के बाद, वॉशिंग करने के बाद, ये बड़े बड़े सिलेंडर देख रहे हैं आप, इनके ऊपर ये धागे जो हैं ये ड्राई हो रहे हैं. और यही धागे आगे जाकर हम वीविंग में इस्तेमाल करते हैं अपना कपड़ा बनाने के लिए, जीन का फैब्रिक. So this is just a brief introduction of the dyes used in the dyeing method. आप मैटर कैसे यूज कर सकते हो, टर्मरिक कैसे यूज कर सकते हो और इंडिगो कैसे डाई कर सकते हो. बट द क्वेश्चन अराइज अबाउट द अवेलेबिलिटी ऑफ द नेचुरल डाई. जो मेन क्वेश्चन हमारा राइज होता है कि जो डाइज की अवेलेबिलिटी क्या है. सो अराउंड ईयरली 8 लाख टन, 8 लाख टन जो है, जो सिंथेटिक डाइज जो है वो प्रोड्यूस होती हैं एनुअली. और उसमें से 70% डाइज जो हैं वो टेक्सटाइल इंडस्ट्री में यूज होती हैं. 25% है वो फूड इंडस्ट्री, टॉय इंडस्ट्री आपकी जो है, और आपकी फार्मास्यूटिकल इंडस्ट्री में यूज होती हैं. और इनमें से सिर्फ 1% नेचुरल डाइज जो है वो कंज्यूम होती हैं. लेकिन उनका 1% होने का कंज्यूम का रीजन क्या है? द रीजन इज द लिमिटेड अवेलेबिलिटी. द नेचुरल डाइज हैव अ लिमिटेड अवेलेबिलिटी and they are subject to be growing season of the plant or the life cycle of the insect from which they have to be dried. So हमने देखा है कि हमने डाई को एक्सट्रैक्ट किया है. सो डाई को चाहे हम प्लांट से लें, चाहे इंसेक्ट से लें, चाहे माइक्रो ऑर्गेनिज्म से लें, तो हमें उनसे एक्सट्रैक्ट करने के लिए उनकी अवेलेबिलिटी होना बहुत जरूरी है. और जो डाइज हैं, these are growing depend upon the season. So ये एक बहुत बड़ा इशू है. सेकंड इशू है द ग्राउंड यूज. सो जो हमारी लिमिटेड, हमारी ऑलरेडी फूड क्राइसिस चल रहे हैं, हमें फूड खाने को नहीं मिल रहा है. सो इट इज अ वेरी बिग चैलेंज दैट हाउ वी विल प्रोड्यूस द नेचुरल डाइज एंड ऑल्सो द कंपटीशन विद द फूड स्टफ प्रोडक्शन. तो मैंने एग्जांपल में ग्रेप्स की बात की है, मैंने अनार की बात की है, मैंने सैफरॉन कलर्स की बात की है, मैंने बीट रूट की बात की है, दैट इज चुकंदर. सो एक तरफ तो हमारा कंपटीशन है फूड स्टफ के लिए, और वहां से डाई एक्सट्रैक्ट करना, दैट इज अगेन अ चैलेंजिंग टास्क. And another is that it is just not enough natural dye production. जैसे मैंने अभी बताया है कि only we need 8 lakh ton. So 8 लाख टन जो नेचुरल डाई प्रोड्यूस करना वो बहुत बड़ा एक इशू है. And another issue being I am from the industry and I have faced this issue. So नेचुरल डाई की रिप्रोड्यूसिबिलिटी एक बहुत बड़ा चैलेंज है. अगर आप बात करो रिप्रोड्यूसिबिलिटी होती क्या है? आप मैं एग्जांपल लेता हूँ, आप किसी मिठाई की दुकान पे जाते हो, तो आप वहां से कोई मिठाई लेके आते हो, आप 10 दिन के बाद फिर जाते हो, फिर मिठाई लेके आते हो, और अगर उसका टेस्ट वही है तो आप उसके बाद दूसरी बार, तीसरी बार, चौथी बार भी जाते हो. दैट इज कॉल्ड रिप्रोड्यूसिबिलिटी. लेकिन अगर आपने नेचुरल डाई यूज की है, आपने कोई प्रोडक्ट को बनाया है, प्रोडक्ट बना के आपने उसको डाई किया है, लेकिन आपको फिर दोबारा से ऑर्डर आ गया कि आपको सेम कलर प्रोड्यूस करना है. दिस इज द वेरी बिग प्रॉब्लम इन द केस ऑफ रिप्रोड्यूसिबिलिटी ऑफ द शेड इन द केस ऑफ नेचुरल डाइज. क्योंकि मैंने आपको बताया है कि सीजन के विद रिस्पेक्ट टू सीजन द कलर ऑफ द फ्लावर्स, द कलर ऑफ द फ्रूट, द कलर ऑफ द वेजिटेबल्स, द कलर ऑफ द लीव्स आल्सो चेंजेस. So this will again a problem in the reproducibility of the shade. That is the reason why the natural dyes are facing a very big issue from the main industry. So what are the disadvantages? Before talking about the disadvantages, I will talk about the negative part of the natural dyes, that they are expensive. So they are taken from the food source. अगर चुकंदर आज की डेट में 20 रुपए किलो है, तो अगर उसमें से डाई निकालनी है, from 1 kg of the beetroot, you can able to extract only 5 gram of the dye. So this is a very challenging task. So that is why they are very expensive. And as I said that the fastness properties are very poor. They faded very easily. So they fade very easily. That is why we are not used for the long term. हमारी जो लंबे हम कोई शर्ट पहनते हैं या ट्राउजर पहनते हैं 1 साल 2 साल 3 साल, so अगर उसको बार बार धोएंगे और बार बार उसको सुखाएंगे, so it will get fade very easily. That is why the natural dyes are the discouraging one. Difficult to produce and collect. एक्सट्रैक्शन करना, एक्सट्रैक्शन के बाद उसको यूज करना, पहले उसको सुखाना, काटना, सुखाना, ये एक लंबा प्रोसेस है, तो इसलिए ये टाइम कंज्यूमिंग भी है. दैट इज व्हाई इट इज वेरी डिफिकल्ट टू यूज द नेचुरल डाई. नॉन स्टैंडर्ड रिप्रोड्यूसिबिलिटी ऑफ शेड, मैंने आपको जैसे बताया था कि रिप्रोड्यूस होना उनका बहुत मुश्किल है. द अनदर टास्क, द अनदर प्रॉब्लम इज द कलर मिक्सिंग. जैसे कि अभी हमने डाई की बात की, इंडिगो डाई करना है, केला डाई कर सकते हो, टर्मरिक डाई करना है, केला डाई कर सकते हो, आप मैडर डाई करना, केला डाई कर सकते हो. लेकिन अगर आपको कोई शेड मैचिंग करानी है, अगर आपको कोई कलर मिक्स करना है, तो कलर मिक्सिंग इज अ प्रॉब्लम. क्यों? क्योंकि टर्मरिक को डाई करने का मेथड अलग है, मैडर को डाई करने का मेथड अलग है, इंडिगो को डाई करने का मेथड अलग है. तो ये अलग अलग मेथड होने की वजह से जो शेड मैचिंग है उसमें बहुत डिफिकल्टी आती है, और हम उसमें अलग अलग नेचुरल डाइज को कंबाइन करके यूज नहीं कर पाते. अगर कुछ नेचुरल डाइज अवेलेबल भी है मार्केट में, तो उनका जो कलर कॉम्बिनेशन है वो मार्केट में एक्सेप्टेबल बहुत कम है. सो अपार्ट फ्रॉम द लॉट ऑफ द डिसएडवांटेजेस, अगेन the benefits we have from the natural dyes, the advantages we have from the natural dyes, which make their place in the market till now, that is the eco-friendly. आप में से कुछ अगर कोई लुधियाने के होंगे, तो लुधियाना में जो आपका जो बुड्ढा दरिया होता था किसी जमाने में, आज की दिन में वो बुड्ढा नाला बन गया है because of the dyes. And the Ludhiana industries have a lot of the dyes manufacturing units, using units. So they release the synthetic dyes and they are not biodegradable and not eco-friendly. That is why the Buddha Darya are now called the Buddha Nala. तो हरीके में भी आप देखोगे तो हरीके में भी कई बार न्यूज में सुनते हैं हम लोग कि बहुत सी मच्छियां मरी पाई गई हैं. तो ये सारी जो रीजंस हैं, ये रीजंस हमें मजबूर कर देते हैं फिर भी नेचुरल डाइज की तरफ. सो नेचुरल डाइज आर इको-फ्रेंडली, they can be extracted and they are environmental safe, they are biodegradable, they are renewable. आप किसी पेड़ से फ्रूट को काट के उसमें से डाई एक्सट्रैक्ट करते हो तो आपको दोबारा से वहां से फ्रूट मिल जाएगा. नो हेल्थ हैजर्ड्स, नॉन टॉक्सिक. टर्मरिक यूज करते हो, आप मैडर यूज करते हो, यू विल ईट इट, यू विल नॉट एबल एनी प्रॉब्लम. देन सूथिंग एंड सॉफ्ट एंड कलर, लस्ट्रस कलर यू कैन गेट. यूटिलाइजेशन ऑफ द वेस्ट मटेरियल, जो डाई एक्सट्रैक्ट करने के बाद जो वेस्ट मटेरियल है, इट कैन बी अगेन यूज फॉर द नेक्स्ट प्रोसेस. And you can also get some of the properties like antibacterial, UV protection from the natural dye. So जो turmeric है वो antibacterial properties देता है, हीना आपको antibacterial properties देती है, UV protection आपको मिलती है. So these dyes also protect you from the dangerous microorganisms and also from the radiations. So this is what the benefits we have from the natural dyes. Regarding their applications, I can have a very one slide which will show their applications. So natural dyes can be applied in the textile field. They can be used as an antimicrobial, as a Jaglon, it can be used as antimicrobial. Then you can use as a UV protection agent. The madder can be used as a UV protective agent. Then you can have a decoration. The food products, you can have a saffron dye as a food product. In the cosmetic industry, henna is widely used for the coloring of the hair also. The drug medicine, the turmeric can be used as a antibacterial medicine. Then the pH indicator, you can use the natural dyes in the solar cell also. So here I wish to say that the natural dyes are having, although they are having a very challenging task for the production or extraction, but apart from these, because of these benefits, they can be widely used in our daily life. So although commercially natural dye facing the challenges, but at least we can use in our domestic purpose for our food production or for our, you can say, art and craft. And this is all about the natural dyes. If you have any question, you can please ask.
Yes, sir. Thank you so much, sir. Dear participants, if you have any questions regarding natural dyeing or the procedure or anything you want to ask from our expert speaker, you can do that, or write in the Zoom chat if you want to. Or raise your hands if you want to ask any question directly. So one question is there in the Zoom chat by AR. I don't know the full name.
Yes, ma'am. Please, ma'am.
Tea or coffee can be used as dye?
Yes, ma'am. I have already shown the dye structure of the tea. The tea can be used as a dye molecule, and it was successfully dye the cotton fiber. But the question rises that whether it should be called as a colorant or not, because when we go to the spectroscopy of the tea, we do not found any peak in the visible range. That is why question is always there on the natural dyes. The tea can be used as a natural dye. It gives the yellowish brown color on the material. But when we check on the color spectroscopy, we found that it do not show any peak in the visible range. So although it gives the color, definitely we can use tea and coffee. But extraction is the challenging task that we have to extract the dye.
Yes, sir. Thank you so much, sir. Any other question from the participant? Hello. Anyone? Yes, sir. One more question is by Dr. K.G. Ahilya. Respected sir, very good session. Is there any type of antimicrobial agents added to this dye to prevent microbial contamination?
Already, I have mentioned in the last slide regarding the applications. You can use an antimicrobial agent as a jugnol. So it can be taken from the walnut inside, and that can be used as an antimicrobial agent. And turmeric also can be used as an antimicrobial agent, and dye itself also.
Yes, sir. Thank you so much, sir. Any other question you want to ask from the speaker of the day? You can unmute yourself. You can raise your hand or write in the Zoom chat. We will make a provision for you. Yes, one more question is from AR, sir. May we see the classification slide? Sir, they want to see the classification slide once again.
The natural dyes can be classified by two ways. The one method is the dye structure, that chemical constitution. And in this, generally, there are a lot of the classes are there, but I have covered only very specific dye structures. The first is the indigo dye, and this gives the blue color, and most of the denim are dyed by the indigo. And I have already told in the presentation that the current indigo dye is a synthetic dye, not extracted from the plant, because the market demand is very huge, and it is very difficult to cover this huge demand. And the second important class is the anthracnone dyes. Anthracnone dyes give the most of the red colorant, and the madder, lac, cochineal neil are the one of the anthracnone based dyes. And in the madder, you can have two major chromophores as alizarin and purpurine. And then alpha naphthoquinones are there, and Hina belong to this dye class. And then flavonoids are there, which give the yellow color. And then the carotenoids are there, which give the red, orange, and yellow color. Apart from these, there are some of the other groups are also there. I wish to mention here that when we talk about the synthetic dyes, most of the synthetic dyes are azo-based, but in the case of natural products, we are not able to get the most of azo dye as a chromophore.
Yes,
And
sir.
these are the structures of some of the dyes.
Yes, sir. Yes, sir. Thank you. Thank you so much, sir. And so my question is, you said that we can take natural dyes from mulberry also. That is the purple or violet, right?
Yes, yes,
So, but
yes.
mulberry trees are nowadays they are vanishing. Like they are extinct. They are becoming extinct species. So, I mean, how can we use mulberry for that purpose? But
That I have already told that many of the species are very now
yes, sir.
not
It
existing in the
becomes
environment.
very rare now.
Now
Yes, sir.
that is a big problem with the natural products.
Yes.
That is a big problem with the natural dyes. That is why their use are very limited. I also try to extend the dye from the mulberry. I give this project to my students, and they have extended the dye. But the challenge is where that these fruits are only available for the few days. In
Yes,
a whole
sir.
year, you can get the dye only for the few days. And out of this, they are very sensitive to air and you can say storm. So during these days, storms are all there. Most of the dyes will get broken down from the tree and get spread down the roads. So it is very difficult to collect them. The difficulty is there. So that is why I said that around 450 plants are there, trees are there which give the dye. And out of these, only 40 to 50 are important. Around 450 plants are there. One of the trees there in the chemistry department, it gave a very fine yellow color. And day before yesterday, there was a rain and the whole floor was yellow colored. But the problem is that dye is very difficult to extract. So challenges are there.
Yes.
Challenges
Thank you, sir.
Yes.
Yes, sir. Thank you so much, sir. Thank you so much, sir. Now, let me share my screen now. Thank you, sir. So I invite our head of the department, Dr. Manju Sani, head of PG Department of Chemistry, for a formal vote of thanks. And she is always a big support to conduct these type of events in our department, sir. So over to Dr. Manju Sani, ma'am.
Thank you, Dr. Narendra. Am I audible?
Yes, ma'am. Yes, ma'am.
Thank you very much. At the outset, we wanted to thank you, sir, for conducting such an informative and engaging workshop. Your knowledge and skills really help us to learn and grow. Hoping such interactions, more interactions. This was just like a interdisciplinary workshop, and we need such type of information and interactive sessions in future. So thank you very much once.
Okay. Thank you, madam.
Thank you, sir. Thank you so much, sir. And thank you, dear participants, for joining us from all over India. So we are having participants from all over India in this workshop. Around 20 states participants have joined us. So thank you, dear participants, and my dear students and faculty members for joining this webinar. Thank you so much. Thank you, sir.